Alright, in this video we're going to look at finding the domain of a function. So the default for finding the domain of the function is you assume that it's going to be all real numbers. So you see that funny looking R there for all real numbers, or an interval notation that's negative infinity to infinity. So the default is going to be all real numbers unless you have a denominator. So we want to make the denominator not equal to 0. Now, from your homework assignment in Math 06, that's it. We're only looking for denominators. However, maybe you're planning on taking college algebra, or you're in college algebra. Then if you have in 2 here, you have the nth root of what we call underneath, we call it the radicand. So we want to keep things real. We don't want any imaginary numbers. So when it's an even root, we want the radicand, which is the stuff that lives under the root. We want it greater than or equal to 0. And then it's just an inequality that you folks know how to solve. And then write the interval notation. You're already good at that. And then something strictly from college algebra and pre-cal is if you have a log, the log, and then inside you're going to have what's called an argument. Logs are happy creatures. They don't like being fed anything negative or 0. So we would say that the argument needs to be greater than 0. So that's what we're looking for. We'll practice an example or two just because it's a good practice of inequalities. Okay. So we'll look at a couple of things where we're going to find the domain. Okay, so our first function is f of x is equal to 12x minus 17. That is a line with a y-intercept of 0, negative 17, and a slope of 12. Okay, so what I'm looking for the domain, default is negative infinity to infinity. No denominator, no square root, no logarithms, no problem. So that does not have any of those. So this has domain all real numbers. We just say negative infinity to infinity. If I look at another one, we'll call it g of x, which is x squared plus 5x plus 6. Okay. Again, we need to pay attention to our instructions. We don't need to go ahead and solve this. I know I see students all the time trying to solve this, but they didn't read the directions. So finding the domain, no denominator here, no square root here, no logarithm here, no problem. Default, all real numbers. We can plug any number in and won't have an undefined or division by 0, imaginary numbers, anything like that. Okay, we'll do a couple more examples. So let's look at this. H of x equals 3 over x minus 7. This does have a denominator, so we're going to set the denominator not equal to 0. So x cannot be 7 when we plus 7 to both sides. I like to draw the number line to kind of help myself picture where things are going. So the only thing we can't be is 7, and I circle it so that we're going to have an open circle there. So where I start is minus infinity, and we go all the way up to 7, and then we got to hop over 7, so we have our union, and we go 7 to infinity. And that's my domain. Okay. We'll do something a little bit more challenging. So let's look at k of x, where we have it equals 5 over x plus 2 minus 3 over x squared plus 13x, and then I didn't do the best job, but it should say plus 36. Okay. Alright, so I have two denominators. That's what I'm going to focus on, and I want those denominators to not equal 0. So on one hand, x plus 2 cannot be 0, and the x squared plus 13x, and I'll do a better job of writing 36, plus 36 cannot be 0. The first one will subtract 2 from both sides and get x cannot be 2. Sorry, not 2, negative 2. And then the second one, we will go ahead and factor it, so it would be x plus 4, x plus 9. Cannot be 0. So that tells me x cannot be negative 4, and x cannot be negative 9. And when I draw the number line here, it's very helpful to have this here to help me write out the interval notation. So negative infinity to infinity, so negative 9, negative 4, and negative 2. Those are the bad points that we're going to have to hop over. So we start at negative infinity, and we can go all the way to negative 9, and then we got to hop over negative 9, and then we pick back up at negative 9 to negative 4. Got to hop over negative 4 to negative 2. Got to hop over negative 2 and negative 2 to infinity. So that number line really helps me out, because a lot of times what happens is I'll forget one of the middle intervals, like negative 9 to negative 4 or negative 4 to negative 2. Okay, so this is probably about as bad as they're going to get in terms of what we'll see in 06. Now, if you're planning on taking college algebra, you can do stuff with both the logarithms and the radicals. And they're really not a big stretch from what you already know how to do. You already are very good at solving inequalities. So m of x equals the square root of 2 minus 5x. The square root is an even root. And the radicand is the 2 minus 5x. We want that to be greater than or equal to 0. So we would subtract 2 from both sides to isolate the minus 5x, and then we would divide both sides by negative 5, and because I divided by a negative, I have to flip the inequality. Okay, and I can draw my number line in to kind of help things out. So our domain will be negative infinity to 2/5 with a bracket at 2/5, and that's all I need to do. Okay, and we'll do one with a logarithm just for fun. So we're going to do log of 5x plus 7. So the argument is 5x plus 7. That needs to be greater than 0, because a log is a happy creature. It does not like negatives, and it does not like zeros. So this turns into something you know how to solve. We're going to isolate by subtracting 7. And then we're going to divide both sides by 5. Because I'm divided by a positive, no need to flip the inequality. So x is greater than negative 7/5. So that would be negative 7/5 to infinity. Okay, so there you are. That's how we find the logs. So for 06, it doesn't have a denominator. If it doesn't, domain's everything. If you're in college algebra or planning on taking college algebra or pre-calc, then you might have to look at the logarithms and the radicals. Okay.